सूरज की किरणें आने दे मेरे मीत, अब चल जाने दे जो भी बीत, ओ जगे ताने दे उनकी सुने ना। देखो सावन आए रे मन हंसाए मितवा, और सारी उम्र ना गवा दे मितवा। क्यों सोचे बादल खरे हैं जबकि वो तो रुके हैं, क्योंकि बारिश तो आनी है ना।
Good morning, students. I hope I'm audible to everyone. Please acknowledge in case I'm audible.
Yes, sir.
Okay, very good.
Sir.
Okay, so since this is going to be the first class where we'll be starting our first chapter, that is computer systems, where we'll be discussing about the basic components of a computer system. Exactly how we'll be learning how a computer system works, and we'll be learning the coordination between the hardware components of a computing system. But before that, since there is also a scenario that most of you even you don't have the books, because last class was the first class where I've introduced like which book to buy, from where to buy. So it might happen that most of you still don't have the book. So in order to get started, what I would recommend is, for the first chapter we'll be following the NCERT book, because both the contents are the same. And what I believe is, in the NCERT book as well, the content in the book has been given in lucid manner. So we'll be following the NCERT book as of the first chapter. By the time, in the meanwhile, I would request each and every one of you to order the book, so that within a week or so you get the delivery, or you get your book. And from the second chapter, or from the next chapter, on next unit onwards, we can get started with the Sumita Arora's book. Okay, so this is what I would like to suggest, and this is what I'd like to recommend to each and every one of you. In order to access, or in order to get the book, what you can do is, you can go to my site, and you can scroll down in the class 11 tab, and here you will get the option to get the NCERT class 11 IP book. So the moment you tap on this, it will redirect you to the official website of NCERT, where you can download the entire book or chapter wise book. I would recommend you to download the chapter 1 as of now, because we'll be discussing the chapter 1 from the NCERT portion. Okay, so let's get started with the first unit, or the first chapter, that is computer systems. So what exactly computer systems are, right? Whenever we talk about computers, computers are those device, let me tell you, computers are those device which perform some sort of computations, but yes, with respect to some sort of logics, and with on the basis of those logics, those computers are being programmed, on those computers are being instructed, and on the basis of those instructions they perform the calculations. Like, you play music, it is performing calculation in the backend. You play a movie, it is performing some sort of calculations in the backend. You play a game, it is performing some sort of calculations in the backend. So any task you name the task, it is performing the calculation. Okay, so that's why the name computer is being given. Like, compute the set of instructions and execute the task. Compute the set of instruction and execute the task. That's why the name computer system has been given. Let me tell you, the calculators that you have in your home, or the calculators that you have seen in shops or in banks or wherever, so all those computers that you see, those digital computers, are basically a computer system. Like, it might be a very small device for us as of today, because it is performing just some sort of simple calculations, which is very simple. Let's say addition of n number of numbers, or multiplication of n number of numbers, or performing any kind of arithmetic operation. But let me tell you, in the backend, since it is performing some sort of calculations, that too with on the basis of some sort of logics, that's why we can also classify those devices to be as the computer systems. Okay, let me tell you, this quote has been given by the father of modern computer science, that is Alan Turing. Who is Alan Turing? As I always say in the introductory class, is the father of modern computer science. And definitely I would recommend each and every one of you to search the web, and at least go for who exactly Alan Turing was, because for the students of IP or for informatics practices, we have a special section for Alan Turing. That is a smart wall magazine which is being named after Alan Turing, and that is basically the Turing point, which is a yearly magazine, and it is an initiative that has to be taken by the class 11 students. Okay, so yes, who exactly Alan Turing is, and what is his contribution towards the field of computer science, or in the field of artificial intelligence, that you will come to know. There is a movie which I recommend to the students when they join the first class of IP, that is the Imitation Games. And those who have watched, it is I believe you will understand that it is a very good movie. In case you have not watched, you can definitely go to the YouTube, and it is available over YouTube. Okay, so yes, introduction to computer systems. So let's get started with what computer systems are. You can see there is a line written over here. A computer system is an electronic device that can be programmed to accept data, process it, and generate result. Okay, so by this we can understand that definitely there is a system, or there is a device which is going to take the input, it is going to process it, and it is going to produce the output. Without the input, it is not going to process any kind of data. For example, as I said, you play music. In order to play music, you need to give the input, or you need to send that play this particular music. You need to tap somewhere, you need to click somewhere, you need to load that particular music. Then only that system, or then only that device will be able to play that particular music, right? Similarly, in case of any other task, let's say calculation of two numbers. In order to perform the calculation of two numbers, you need to give those two numbers as an input to the system. Then only that particular system will be able to perform that calculation. So in a nutshell, we can say that computer systems are basically those systems which will definitely take or accept some sort of inputs, and after receiving the input, it is going to process those particular inputs and going to give you the output as a result on behalf of those inputs that you have supplied. Okay, so if you supply a garbage input, it will definitely give you the garbage output. But if you give a proper input, then in that case it will be able to process it properly, and it is going to give you the proper output. So there is a term called gigo. Okay, there is a term called gigo. I don't know how many of you have heard about. Gigo is basically garbage in, garbage out. Okay, garbage in, garbage out. You give the garbage to the computer system, it will give you the garbage as an output to the computer system. Let's say you're expecting this. Okay, you're expecting this. Let's go to our drawing board. Okay, for example, we want to perform this arithmetic, or we want to evaluate this expression. Okay, 2 plus 2 into, let's say, 3. Can anybody tell me what is the output of this expression? What is the output that we are going to get?
12.
12.
Very good. Okay, we are going to get the output to be as 12, because it will this values within the parenthesis, or this values within the brackets, will get evaluated first, and then it will get multiplied with 3. But what if I want the output something like this? Okay, I want to multiply 3 with 2 first, then add it with 2. So what is the output in this case? Can anybody tell me?
8. 8.
8.
Very good. Okay, I want this output, right? I want this output, but I have written the expression in this way. So this is basically what exactly garbage in, garbage out is, right? You're giving some sort of wrong values. You're evaluating, or you are formatting those values in a format which you don't want, but you're expecting something like this. Okay, so it is not the fault of a computer. Okay, it is not the fault of a computer. It is the fault of the humans. Okay, it is the fault of the humans. Okay, so that's why we call the term to be as garbage in, garbage out, because the moment you supply the input to be as garbage, you're going to definitely get the output to be as a garbage value. Okay, a computer system primarily comprises of a central processing unit, memory, input output devices, and storage devices. All these components function together as a single unit to deliver the desired output. Okay, like as I said, all those hardware components needs to coordinate with each and every other components. Like if the motherboard says, okay, you are running a computer system, I won't coordinate with the processor. In that case, you won't get the output, because your motherboard is not coordinating. Okay, this situations might even occur when situations might even occur when the hardwares fail, or when there is hardware failure. Let's say there is a spike in a voltage, there is a sudden spike in voltage, and your motherboard got burnt. Okay, or your motherboard got fired. In that case, you will see that there is a lack of coordination. There is a lack of coordination between the hardware components. So it is very important to coordinate between each and every component, so in order to process the input properly, so that the resultant output can be displayed to the user. Okay, yes, like as we know, uh, as of now, computers come of in a different shape and size. Okay, so there was a time when the shape or when the size of a computer to be as large as a room, right? But as of now, as of today, even computers they have or they come in a size smaller as even a size of credit card. Okay, we can take the example of the famous Raspberry Pi. Okay, so those who don't know what exactly Raspberry Pi is and are interested in and are interested to pursue the further studies in computation, then definitely you must go for this computer. It is a credit card size computer. It will definitely help you in developing your small or large scale projects or prototype projects. Like let me show you what exactly this Raspberry Pi looks like. Okay, so this is what exactly Raspberry Pi is. Okay, so this is a very small credit card shaped computer, and yes, this has got lot many potentials. Like if you need to perform, if you need to do some sort of automation, if you need to control if you need to automate the stuff like smart home systems, or if you need to develop a smart home system of your own, or if you need to collect data, if you need to collect data using various sensors, then this kind of computers are really very helpful. Okay, so you can get one from Amazon. Okay, the cost is most probably 3,500 or 4,000, something like that. It will be 4,000 plus for the latest model, but for the models like Raspberry Pi 3 or 3B, it will be around 3,500 or 4,000. Okay, so this is the cost of Raspberry Pi. Okay, uh, okay, very good, Rishi Saikia. It is very good to see that one of you have this Raspberry Pi. There are also many models available for this Raspberry Pi. This is the Raspberry Pi 3. In case if you're going to get started with your projects, if you want to know something about this device, there is also one device that is available, Raspberry Pi Zero, which is even smaller than the Raspberry Pi 3. So this is the size of Raspberry Pi Zero. Okay, so this will perform the same as of Raspberry Pi 3. But yes, the features are less. There are less number of ports available, and but yes, if you need to automate the stuffs, then you can definitely go with this as well. Okay. So this was all about the Raspberry Pi or the size of a computer as of today. But if we talk about the size of a computer in early 1970s or 1960s, okay, or 1940s, you can see first computer. If I type in Google the first computer, you can see this is approximate size of a computer. You can see over here. And if you talk about the computation power of this computer, this was not even powerful if you compare with today's credit card size computers like Raspberry Pi. This was not even powerful up to that mark, right? Today's Raspberry Pi has got the potential to process graphical data, like you can click on some sort of objects, you can get the output, you can click some sort of objects in sort of objects, and you can give the input to the computer system. So all these things can be done, right? But if you talk about this computers didn't have the capability to process graphical data. So these computers were not even that powerful even if you compare it with today's computers, right? So yes, the size of computer, the capability to process data, or the power of a computer got drastically changed when we compare it with the first stage to as of now, right? The size has decreased in a large extent, and the power has also increased up to a yes, the power has increased exponentially for each and every computing devices. Yes, this is how exactly what exactly is the current situation of all the computing devices are, right? From high-end server machines to personal desktops, laptops, tablet computers, or smartphones. So all these are the various type of shapes and size where the computations are being done, and yes, and how the computers are designed. Okay, so if you talk about your smartphones are as well as the computers. Even your feature phones are also the computers. They also have the RAMs, they also have the ROM, they also have an operating system by which you give the instructions to these phones, and they perform some sort of task. Okay, so if you talk about the basic component of a computer system, let me tell you, this is the basic component of a computer system, where, as I said, input will be given to the system, that input will be processed, and it will get the resultant output. While processing, or while giving the input to the system, it will definitely transfer the input to the CPU. Yeah, whenever we talk about CPU, yes, students, those who are new for this class, those who have not attended the bridge course of class 11, then in that case, let me tell you that CPUs are some sort of different things. Okay, CPU are some sort of different things. Those who have attended, I would like to see the answer. Let me tell you, let me show you the images of CPU. Okay, now let me ask whether this particular device or this is a CPU or not. Do you believe? How many of you believe that this is a CPU? Those who have attended the bridge courses, do you uh, do you believe that this is a CPU or this is a CPU? Which one do you believe? Is it a CPU or this CPU?
So the left one is CPU.
The left one. Yes.
Left one is CPU, exactly. So this processor that you see, these are basically the CPUs. And what is this then?
This is
So
just
it's
the
a cabinet.
cabinet.
Exactly, these
Yes,
are the
it's a
cabinets. So
cabinet.
whenever we talk about central processing unit, remember students that we are definitely dealing with this microprocessor. We are definitely dealing with this microprocessor. We're not dealing with this entire cabinet. Okay. So yes, so this central processing unit will have primary memory, control unit, arithmetic logic unit. Okay, so whenever we talk about primary memories, these primary memories are basically the RAM and ROMs. Okay, the RAM and ROM. Okay, and if you talk about the secondary storage devices, so secondary storage devices are devices like the hard disk drive, the solid state drives, pan drives, CD drives, etc. Okay, what is the difference between secondary storage device and primary storage device? We'll come to know very soon. But let me tell you that the moment the computer receives the input, it will definitely transfer the input to the central processing unit. And whenever we're talking about central processing unit, we are basically dealing with this microprocessor. Okay. Yes.
Sir,
Yes, please.
why is SSD faster than HDD?
Okay, if you talk about SSD, solid state drives are those components or those hardware devices. Those who don't know what exactly solid state drives are, let me show you. So this is what a solid state drive looks like. Okay, so this is not a solid state drive. Yes, this is what a solid state drive looks like. You can see there is a comparison between HDDs and solid state drives. Solid state drives are basically based on semiconductors, right? There is a chip over here, and this chip is completely based on semiconductor device. You will be learning about semiconductors in physics, I think in class 12, what exactly semiconductors are. So this are between this device or this components are between conductivity and non-conductivity of electricity. You will come to know in physics. But if you talk about hard disk drives, so hard disk drive, there is a motor over here, and there is a motor, and there is a disk over here, and there is a platter over here. There's a read write read. So there is a lot of mechanical components that goes in the back end of a hard disk drive. Remember, there is a lot of mechanical components. So whenever you plug or play a hard disk drive, all those mechanical components starts revolving, like the disk starts rotating, and the read and write of data starts happening. So there is a concept of a magnetic field. So the magnetic field gets generated over this sectors, and the read and write of data starts happening. But if you talk about solid state drive, the case is not like that. There are no mechanical components. All those components that you have are completely digital. Okay, so I hope I'm able to answer your query.
Yes, sir.
Okay, so whenever we talk about SSDs are much more faster. The first reason, there are no mechanical components. Second reason, SSDs work on completely semiconductors device. And if you talk about HDDs work on magnetic field. So yes, definitely there will be a delay in reading and writing of data. Okay, so since all those mechanical components will start moving or start rotating, so there will be definitely some sort of delay while reading or while writing of data. Okay, so yes, all those are secondary memories. We'll come to that part. Let me tell you, let me get started with the arithmetic logic unit. What exactly arithmetic logic unit is? Okay, so arithmetic logic unit, by the name itself, you can understand that this is that particular unit of a CPU which will perform some sort of arithmetic calculations. So whenever we talk about arithmetic calculations, yes, you're getting it absolutely correct, like addition, subtraction, multiplication, all those calculations that will be done by this arithmetic logic unit. Okay, and yes, there will be one more unit, that is the control unit, which will control the flow of data within the systems, like which from which component to which component that data will be flown. Okay, and which path to select in order to transmit that data, that will be seen in a practical perspective very soon. And there is one more component, that is the primary memory. Yes, why we call that memory to be as primary memory? The reason is because without that memory you cannot run a computer. You can say that yes, I can run a computer without the secondary storage device, but if I say that can you run a system or can you run a computer without the primary memory, the answer is absolutely no. You cannot run a system or you cannot run any computing device without the primary memory. The reason is because the moment you inject the input, the input will get towards the primary memory. The input will get towards the primary memory, and yes, from the primary memory, with the help of the control unit, it will be transmitted to the arithmetic logic unit, so that some sort of arithmetical operations can be done within through that input. Okay, if this flow from primary memory to ALU is clear, I would expect a thumbs up in the chat box ASAP. As I always say, if you don't give thumbs down as of now, then in the exam I will be giving thumbs down to you. So this is your time to give thumbs down. Remember, the 10 marks is coming from this chapter. टोटल 10 मार्क्स आ रहे हैं इस चैप्टर से. So this is how exactly the input or how exactly the processing of a system works, like from primary memory to arithmetic logic unit. Okay, so now let me show you the pictorial representation or how exactly the motherboard looks like. Okay, I believe you have seen some sort of circuits or some sort of yes, some sort of chips or some sort of PCBs that are printed circuit boards. Okay, so whenever you go by this motherboards or you go by this PCBs, you will see yes, you will see there are some sort of lines over here. How many of you have seen these lines? Please reply in the chat box. There are some sort of lines that are being made. So are these lines for design purpose? How many of you have seen? Those who have seen, please type Y in the chat box. Okay, Rahul Lamba has seen, Arman Das, Sarat Chetia, Dipanga, New. Okay, you have seen those lines. Okay, so these are basically the path. These are basically the path which will be followed or which will be used in order to transmit the data. Okay, these are basically the path. Okay, or these are the connectors which are connecting the components within the various components of this motherboard. Control unit has the power or has the potential to control the flow of data. Control unit has got the potential to control the flow of data. Okay, so here we have the arithmetic logic unit. So if you talk like where is the arithmetic logic unit in a computer, so the arithmetic logic unit is inside the CPU in a computer. Okay, the arithmetic logic unit is inside the CPU in a computer. So if I say, so this is a processor, these are the legs of the processor. You can see there's a section of ALU, the control unit over here, which will once again, this is the control unit of this particular CPU, right, which will maintain the flow of yes, which will maintain the flow of the data from memory to the registers and all. Okay, so this is the control unit for this CPU. Okay, yes, because within the CPU as well, there will be some sort of sections, or there will be necessary need to maintain the flow of data within the CPU. You will require to transmit, or you will require the flow of data to happen, because there are registers memory, and in the memory also you will be storing some sort of data temporarily while processing, because while processing there will be requirement where you need to store the data temporarily. Okay, for an instance, you can understand it like this. For example, there is this instruction that is going to happen 2 plus 2 into 3. Let's say this portion is going to evaluate first, which is practically true, like 2 plus 2 will be evaluated first. The moment it will store the output, it won't store the output in some sort of different memory. It will definitely store the output in the memory within the CPU, but that again needs to be flown, and that flow will be controlled by the control unit of the CPU. Okay, so yes, even in the picture you can see that this control unit that you see over here, is within a particular block. Okay, is within a particular block. Even the primary memory that you see over here is within a particular block, because all these three components are integrated strongly. Even the memory that you have in the CPU is considered to be as the primary memory, because if you don't have any memory in CPU, in that case the processing will be delayed and you won't be able to see any sort of processing happening within that CPU. Because as I said, in order to process for temporary purpose, we need to store some sort of data, because processing करते वक्त भी तुम्हें data कहीं ना कहीं पर तुम्हें store करना पड़ेगा. right? So for example, if I say that perform this calculation manually, in order to perform this calculation manually, okay, 2 plus 2 into 3, obviously your brain is going to store 2 plus 2, evaluate 2 plus 2 and going to store somewhere in the brain, then it will definitely multiply with 3. So if you don't have the capability to store it, in that case you won't be able to evaluate it. Similarly, the same thing is for the CPU as well. Okay. Yes, remember the CPU has three major components. If you talk primary memory, control unit, arithmetic logic unit. And in the primary memory, if you talk about the primary memories of CPU are basically the cache memory, the registers. So what exactly the cache memories are, what exactly the registers are, we will try to understand. Okay. But yes, do remember, whenever we talk about primary memories of a computer system, we basically mean that we are dealing with RAM and ROM. We are dealing with RAM and ROM. Okay. And if we talk about primary memory of a CPU, we are basically dealing with cache memory and the registers. I hope this portion is clear. And we also have that arithmetic logic unit who is going to perform those arithmetic calculations. So whenever we talk about binary digits, because we know that computers, they understand only binary digits. They only understand binary digits. So in case of binary digits, there will be only subtraction and addition. That's it. Okay. Yes, but again, those components or those things fall under the category of arithmetic logic unit, since there are some sort of arithmetic logical operations that goes in the backend. That's why we'll be taking the help of this ALU in order to perform those operations. Okay. So in case if you have any query from the CPU, you can ask. Please remember, the input will go towards the CPU. The CPU will basically have three primary components: primary memory, control unit, and the arithmetic logic unit. Primary memory will store that particular data that you have sent. The control unit will basically transmit the data to ALU. From ALU, when the data is getting when the processing of data is completed, it will once again get transmitted to the primary memory with the help of this control unit itself. And after completing the process, you will get the resultant output in the output window or in the output device. If the entire portion of computer system is clear, I'd request each and every one of you to type CS in the chat box. In case if you have any queries, you can ask. Just type CS in the chat box. If you have, let's say, if you have a dual core processor, then definitely you have two cores in the processor. If you have quad core, you will have four number of cores. If you have hexa-core processor, you will be having four number of cores. So what exactly cores are, that also I will explain. Since yes, Shashwat has raised the topic, let me explain what exactly cores are in a nutshell, so that you don't get messed up or you don't feel like, okay, we don't know about cores, so we are not able to understand what exactly Sir is explaining. Okay, let me tell you. Okay. Let me tell you the story. Let me tell you this in a story format. Okay. Let's say you are in a classroom. Okay, you're in a classroom which is 1 kilometer far away from my lab. Please try to listen to it very carefully. You are in a classroom which is 1 kilometer far away from my lab. Okay. Now, in that classroom, there is a bucket. There is a bucket filled with water. There is a bucket filled with water, and the amount of water that is being filled, that is there in the bucket, is, let's say, that bucket has got the capability to store 5 liters of water. 5 liters of water, and I'm asking, okay, XYZ, please go to that classroom and bring that bucket of water. There are total 4 buckets. Okay, there are total 4 buckets of 5 liters, and that is in that particular classroom. I need to travel 1 kilometer from that portion to my lab. I need to keep that bucket. Okay, let's say, in order to pick a bucket and in order to keep it in my lab, you require 5 minutes. So what is the total number of minutes you would take in order to transmit all those 4 buckets?
So can you repeat the last part?
Okay. Which part? The transmission part?
Yes, sir.
Okay. There is a bucket in the classroom, and in order to carry that bucket and in order to keep it in my lab, you will require 5 minutes. So what is the total number of time that you will require to transmit that bucket from that classroom to my lab?
So 20
20
minutes.
20 minutes.
Minutes.
जाने को कौन पकड़ेगा? तुम बस आएगा क्या? जाने के लिए भी तो तुमको
So
जाना
40
पड़ेगा.
minutes.
Okay, okay. Approx 40 minutes, because obviously while going to that particular classroom, it is not going to take 5 minutes, because in this case you won't be having the bucket. So average एक निकाल लेते हैं, 40 minutes पकड़ लेते हैं. Okay, let us assume that you are going to take 40 minutes. Okay, you are going to take 40 minutes in order to complete that task. Okay, यानी 4 buckets को एक point से दूसरे point तक लाने के लिए you will be requiring 40 minutes. Okay, let us assume this is a hypothetical situation. Okay, so that you can understand the number of cores of your processor. Okay, now what if I say, let's say along with Rishi, let me say that Arman Das will be assisting you. Rishi will carry one bucket, Arman Das is going to carry one bucket. So what is the total number of minutes that you're going to take?
The 20.
So I hope you are able to understand. With the increase of number of people, the time got reduced, right? The same thing is going to happen for number of cores. The more number of cores you have, the more faster the processing is going to happen, because all those cores are going to work together in order to complete the task. How many of you have understood? If you have understood, please give double Y in the chat box. This is the most simplest example that I can give in order to make you understand the number of cores of a processor. Okay, so this was all about today's class, where we have learned about central processing unit, input devices, and the output devices. In the next class, what we'll do is we'll learn about these components in a much more detailed way, as well as we'll try to explore the secondary storage devices of a computer system. Okay, that's it for today's class. Thank you so much, students, for attending this class. Let's meet tomorrow.
सूरज की किरणें आने दे मेरे मीत, अब चल जाने दे जो भी बीत, ओ जगे ताने पे ताने दे उनकी, सुने ना देखो सावन आए रे मन हंसाए मितवा, और सारी उम्र ना गवा दे मितवा, क्यों सोचे बादल खरे हैं जबकि वो तो रुके हैं